Hello everyone, welcome to my YouTube channel. In this video, we are going to see some more questions from forces, moments and couples. So the first question is, a number of forces acting simultaneously on a particle of a body. Option A may not be replaced by a single force. Option B may be replaced by a single force. Option C may be replaced by a couple. Option D may be replaced by a force through the center of gravity. If a number of forces, say P, Q, etc., are acting on a single point or a particle, then it is possible to find a single force which can replace these number of forces. Okay, in engineering mechanics, a particle is an idealization. A particle is a point having no size and have a particular or definite mass. Okay, if forces are acting on this point or particle, then we can find a single force which can replace the given number of forces. This single force is called resultant force, and this resultant force will produce the same effect as produced by all the given forces. And the given forces P, Q, etc. are called component forces. So the correct answer is option B. A number of forces acting simultaneously on a particle of a body may be replaced by a single force. Now the next question is, the process of finding out the resultant force is called. Option A, composition. Option B, resolution of forces. Okay. The process of finding out the resultant force of a number of given forces is called composition of forces or compounding of forces. So the correct answer is composition. The process of finding out the resultant force is called composition of forces. The next question is, if a number of forces are acting simultaneously on a particle, then the resultant of these forces will have the same effect as that of applied forces. This principle is called option A, principle of physical independence of forces. Option B, principle of transmissibility of forces. Option C, principle of reduction of forces. Option D, none of these. The correct answer is option A. Principle of physical independence of forces states that if a number of forces are acting simultaneously on a particle, then the resultant of these forces will have the same effect as produced by all forces. Okay. The next question is, according to law of triangle of forces, option A, three forces acting at a point can be represented by the side of a triangle, each side being in proportion to the force. Option B, three forces acting along the sides of a triangle are always in equilibrium. Option C, if three forces acting on a point can be represented in magnitude and direction by the sides of a triangle taken in order, these will be in equilibrium. Option D, if three forces acting at a point are in equilibrium, each force is perpendicular to the sine of the angle between the other two. Option E, if the forces acting on a particle be represented in magnitude and direction by the two sides of a triangle taken in order, their resultant will be represented in magnitude and direction by the third side of the triangle taken in opposite order. Triangle law of forces is a way to find the resultant of two forces acting at a point. Okay, and triangle law of forces states that if two forces acting on a body is represented in magnitude and direction by two sides of a triangle taken in order, then the resultant is the closing side of the triangle taken in opposite order. So if we have two forces P and Q acting at a point, then we can represent these two forces as two sides of triangle taken in order. If we are taking P as the first side, then we need to take Q from the ending of P, and then the resultant will be the third side, okay, closing side, and taken in opposite order. So we are taking P in this manner and Q in this manner, and then resultant will be from here to here. Okay, so the correct answer is option E. According to law of triangle of forces, if the forces acting on a particle be represented in magnitude and direction by the two sides of a triangle taken in order, the resultant will be represented in magnitude and direction by the third side of the triangle taken in opposite order. Option D is Lamy's principle. Okay, we will see this in subsequent videos. Now, three forces acting along the sides of a triangle are always in equilibrium is also correct, but it is not law of triangle of forces. Okay, we will see more in equilibrium. Okay, we will see in subsequent videos. Now, moving on to the next question. Parallelogram law of forces states that if two forces acting simultaneously on a particle be represented in magnitude and direction by two adjacent sides of a parallelogram, the resultant may be represented in magnitude and direction by option A, its longer side, option B, its shorter side, option C, the diagonal of the parallelogram which does not pass through the point of intersection of the forces, option D, the diagonal of the parallelogram which passes through the point of intersection of forces, option E, half the sum of the diagonals. Now, parallelogram law of forces is also another method to find the resultant of two forces acting on a particle. Okay, it states that if two forces are represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant is the diagonal which passes through the point of intersection. So if we have two forces P and Q, then we can represent these forces as two sides of a parallelogram. So in order to complete this parallelogram, we draw two lines, okay, parallel to both P and Q. Then the resultant will be the diagonal which passes through the point of intersection. Okay. So the correct answer is option D. Parallelogram law of forces states that if two forces acting simultaneously on a particle be represented in magnitude and direction by two adjacent sides of a parallelogram, their resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through the point of intersection of forces. Now moving on to the next question. The law of Polygon Law of Forces states that option A, if a polygon representing the forces acting at a point in a body is closed, the forces are in equilibrium. Option B, if forces acting on a point can be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of the forces will be represented in magnitude and direction by the closing side of the polygon. Option C, if forces acting on a point can be represented in magnitude and direction by the sides of a polygon taken in order, the resultant will be represented in magnitude and direction by the closing side of the polygon taken in opposite order. Option D, if forces acting on a point can be represented in magnitude and direction by the sides of a polygon in order, the forces are in equilibrium. So Polygon law of forces is an extension of triangle law of forces. Okay, it states that if a number of forces acting simultaneously on a particle be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon taken in order. Okay, this law is used if you have number of forces acting on a particle. So if you can see the figure, P1, P2, P3, P4, etc. are the forces acting on a particle. Okay, then we are going to represent it as sides of a polygon. So we need to arrange it end to end. Okay, then if it is open, then the resultant is the closing side taken in order. Okay, so the correct answer is option C. The law of Polygon of Forces states that if forces acting on a point can be represented in magnitude and direction by the sides of a polygon taken in order, the resultant will be represented in magnitude and direction by the closing side of the polygon taken in opposite order. So this is an important phrase. Okay, it should the resultant is in opposite order. So option B does not have this phrase, that is the resultant should be in opposite order. And option A and option D are similar because it states that if the polygon representing the forces acting at a point in a body is closed, then the forces are in equilibrium, which is true. Okay, this is correct. This is correct statement that we will see in equilibrium of forces. Similarly, option D is also correct. Okay, option D is correct only if this polygon is closed. So the next question, if two forces S and T acting at a point can be represented in magnitude and direction by the two adjacent sides OA and OB of a parallelogram OACB, then the resultant is represented in magnitude and direction by option A BC, option B AB, option C OB, option D OC. In order to answer that, we need to draw the parallelogram. Here it's been given that in the questions it's given that two forces S and T acting at a point can be represented in magnitude and direction by the two adjacent sides OA and OB. So you need to draw this OA and OB. Then the parallelogram will be OACB. Then according to Parallelogram Law of Forces, the resultant is the diagonal which passes through the point of intersection. So the point of intersection is O, therefore the resultant is the diagonal OC. So the correct answer is option D. Now the next question. The resultant of two forces P and Q acting at an angle theta is equal to option A square root of P square plus Q square plus 2 PQ sin theta, option B square root of P square plus Q square plus 2 PQ cos theta, option C square root of P square plus Q square minus 2 PQ sin theta, option D square root of P square plus Q square minus 2 PQ cos theta. Now, the resultant of two forces using parallelogram law of forces can be expressed mathematically as resultant R is equal to square root of P square plus Q square plus 2 PQ cos theta. We can derive this equation from the diagram. Okay, I had drawn this diagram, and OACB is a parallelogram. Resultant will be the diagonal passing through the point of intersection of P and Q. Okay, then we need to extend it so that CD is perpendicular to OD. Then we can find the resultant from the triangle OCD. We have hypotenuse is equal to base square square root of base square plus height squared. Okay, hypotenuse square is equal to base square plus height square, or hypotenuse is equal to square root of base square plus height squared. Okay, so base is OA plus AD. OA is equal to P. Then from this small triangle ACD, we can find that AD is equal to Q cos theta. So that base is equal to P plus Q cos theta and height will be Q sin theta. So hypotenuse is equal to square root of P plus Q cos theta squared, then plus Q sin theta squared. So simplifying, we will get P square plus Q square plus 2 PQ cos theta, because the square of OD contains P and Q cos theta, so that the expansion will be P square plus 2 PQ cos theta plus Q square cos square theta, and then we have height squared, which will be Q sin theta the whole square. So taking common from Q square sin square theta and Q square cos square theta, we'll have just we'll get the result as resultant is equal to square root of P square plus Q square plus 2 PQ cos theta. Okay, I would recommend to work this out, but you can directly study this result. Okay, this result is important. The resultant of two forces P and Q acting at an angle theta is equal to square root of P square plus Q square plus 2 PQ cos theta. Okay, the correct answer is option B. The next question is, if the resultant of two forces P and Q acting at an angle theta makes an angle alpha with P, then tan alpha is equal to option A, P sin theta divided by P plus Q cos theta, option B, Q sin theta divided by P plus Q cos theta, option C, P sin theta divided by P minus Q cos theta, option D, Q sin theta divided by P minus Q cos theta. Again, from parallelogram law of forces, we can find the angle that the resultant will make with the force P. Okay, from triangle OCD. Okay, we need to find this angle alpha. From triangle OCD, if we look, we can say that tan alpha is equal to opposite side, which will be CD divided by OD. Opposite side CD is equal to Q sin theta. Okay, from triangle ACD, CD will be equal to Q sin theta, and then AD will be equal to P plus Q cos theta. Okay, so tan alpha is equal to Q sin theta divided by P plus Q cos theta. So the correct answer is option B. If the resultant of two forces P and Q acting at an angle theta makes an angle alpha with P, then tan alpha is equal to Q sin theta divided by P plus Q cos theta. Okay, let's see the next question. If the resultant of two forces A and B acting at an angle alpha makes an angle theta with A, then option A, tan alpha is equal to A sin theta divided by B plus A cos theta. Tan theta, option B is tan theta is equal to A sin alpha divided by B plus A cos alpha. Option C is tan alpha is equal to B sin theta divided by A plus B cos theta. And option D is tan theta is equal to B sin alpha divided by A plus B cos alpha. Okay, we have seen that the angle alpha that the resultant will make with P is equal to Q sin theta divided by P plus Q cos theta. So in this problem, theta is the angle between P and Q. Okay, in this diagram, theta is the angle between P and Q. But in the question, it's given that two forces A and B is acting at an angle alpha, and the resultant is making an angle theta with A. So substituting, we will get here the angle between the resultant and the first force is theta. So tan theta is equal to the second force B sin alpha, because alpha is the angle between the forces. Okay, here in the equation, general equation, theta is the angle between the forces P and Q. So in the question, alpha is the angle between the forces A and B. So the answer is B sin alpha divided by A plus B cos alpha. So the correct answer is option D. Tan theta is equal to B sin alpha divided by A plus B cos alpha. Okay. You just need to study this equation. Okay. Tan alpha is equal to Q sin theta divided by P plus Q cos theta. We just need to memorize this equation and then substitute accordingly. Then we can simply answer this question. Now the next question. The angle between two forces when the resultant is maximum and minimum respectively are option A 0 degree and 180 degree, option B 180 degree and 360 degree, option C 90 degree and 180 degree, option D 90 degree and 360 degree. Now we have the resultant is equal to square root of P square plus Q square plus 2PQ cos theta. We need to find when the resultant will be maximum or minimum. So the variable will be cos theta, it will be theta. The angle between the forces will be varying, and we need to find when the resultant of these two forces will be maximum and minimum. So in order to find that, we just need to find the derivative of this function with respect to theta and equate it to 0 to get the points at which this function will be either maximum or minimum. Okay, So if we find the derivative of this function, we will get, first of all, we need to consider this as a function of function. Okay, we need to apply the chain rule of differentiation. So first we need to assume that p square plus q square plus 2pq cos theta is equal to some other function u, and then differentiate this. So derivative of root of u will be 1 by 2 root u, and then we need to multiply it with the derivative of u. Okay, so the derivative of the resultant, which is a function of theta with respect to theta, will be 1 by 2 root u. U is equal to p square plus q square plus 2pq cos theta, and then the derivative of u, which will be p square and q square are constants, so there will be no derivative, or the derivative will be 0, and then it's 2pq into cos theta's derivative will be minus sin theta. Okay, and then we need to equate this derivative to 0 to get the critical points. The critical points are the points at which the function can be maximum or minimum. Okay, so equating the derivative to 0, we will get minus pq sin theta divided by square root of p square plus q square plus 2pq cos theta is equal to 0. So for this function to be 0, we only have one possibility: sin theta should be 0, because the numerator, in the numerator, p and q are non-zero forces. These are given forces, so sin theta should be 0 for this equation to be satisfied. Okay, which means that sin theta is equal to sin 0, therefore theta is equal to n pi. This is the general solution for sin theta is equal to sin 0. The general solution for sin theta is equal to sin 0 is theta is equal to n pi, where n is an element of integer. N can be 0, 1, 2, 3, or -1, -2, -3, etc. But in this question we have two forces, and the values of the angles between these two forces can vary from 0 to 180 degree. So our angles, okay, the possible values of angles can be either 0 or pi, which means that it can be either 0 or 180 degree. Okay, moreover, we need to find at which point r theta will be maximum or minimum. For that we need to use these conditions. R theta will be minimum if d square r divided by d theta square is positive at a critical point, and r theta will be maximum if d square r divided by d theta square is less than 0 or negative at critical point. Okay, so if we work out these, then we can get that the resultant will be maximum when theta is equal to 0 degree, and resultant will be minimum when theta is equal to 180 degree. Therefore the correct answer is option A. The angle between two forces when the resultant is maximum and minimum respectively are 0 degree and 180 degree. This is the way this is the way to find or to solve this question. Okay, so the results are important for PSC or SSC points of view, and we only get a very limited time to solve the questions. Okay, so the angle between two forces when the resultant is maximum is 0 degree, and when the resultant is minimum is 180 degree. Now the next question is, if two forces P and Q, P greater than Q, act on the same straight line but in opposite direction, their resultant is option A P plus Q, option B P minus Q, option C P divided by Q, option D Q minus P. Okay, now we have P acting opposite to Q, or Q acting opposite to P. So if we draw this diagram, we can say that the angle between the forces is 180 degree. So substituting in the general equation, the resultant of two forces is equal to square root of p square plus q square plus 2pq cos theta. We will get cos 180 degree, and cos 180 degree is -1. So that r is equal to square root of p square plus q square plus 2pq into -1, which will give p square plus q square minus 2pq in this root, and this is a general form, like a minus b the whole square is equal to a square plus b square minus 2ab. So simplifying, we'll get square root of p minus q the whole square, and taking and the simplified result will be resultant of two forces is equal to p minus q. The forces are acting opposite to each other, and if p is greater than q, then we can say it's p minus q. Okay, so the correct answer is option B. If two forces p and q act on the same straight line but in opposite direction, the resultant is p minus q. From this result, we can say that if forces lie on the same line, then we can simply add or subtract the magnitudes based on the direction of the forces. So we just need to consider one direction of force as positive, then the other direction of force will be negative. So we can say that it will be p minus q. Now the next question is, the resultant of two equal forces F acting in opposite directions will be option A 2F, option B square root of 2F, option C 0.707F, option D 0. We have already seen that if two forces act opposite to each other on a same straight line, then the resultant will be p minus q. If these forces are equal, then the resultant will be F minus F is equal to 0. Okay, so the correct answer is option D 0. The resultant of two equal forces F acting in opposite direction will be 0. Now the next question. If the resultant of two equal forces has the same magnitude as either of the forces, then the angle between the two forces is option A 30 degree, option B 60 degree, option C 90 degree, option D 120 degree. Now we have the resultant is equal to square root of p square plus q square plus 2pq cos theta. Given that we have two equal forces and the resultant is also equal to one of the forces, or the magnitude of the resultant is equal to the forces. So substituting, capital F is equal to square root of f square plus 2f square cos theta, which means that f is equal to square root of 2f square into 1 plus cos theta. Now 1 plus cos theta is equal to 2 cos square theta by 2. Okay, so simplifying, we'll get f is equal to 2f cos theta by 2. Now taking it to one side and taking the common factor f, we can say that f into 2 cos theta by 2 minus 1 is equal to 0. So we have f as non-zero. Therefore 2 cos theta by 2 minus 1 should be equal to 0. And simplifying, we'll get cos theta by 2 is equal to 1 by 2. Now cosine of 60 degree is 1 by 2. Therefore we can say that theta by 2 is equal to 60 degrees. Okay, if you are considering 0 to 180 degrees. Okay, because the angle between two forces can be either any angle between 0 to 180 degree. Okay, so cosine is positive in first quadrant and fourth quadrant. Okay, which means that in 0 to 180 degree cosine is positive only in first quadrant from 0 to 90 degree, and in this quadrant the angle having its cosine as 1 by 2 will be 60 degree. Okay, the general solution is different. Okay, so since our possible values for angle is in between 0 and 180 degree, we can say that theta by 2 is equal to 60 degree, and simplifying, we will get theta as 120 degree. Therefore the correct answer is option D. So try to study this or memorize this result. Okay, if the resultant of two equal forces has the same magnitude as either of the forces, then the angle between the two forces is 120 degree. Okay, you can find the answer like this, but it is better to memorize, because in PSC or SSC we need to answer the questions as soon as possible. Now the next question is, the resultant of two forces P and Q is R. If Q is doubled, then the resultant is perpendicular to P. Then option A, P is equal to Q. Option B, Q is equal to R. Option C, Q is equal to 2R. Option D, none of this. The question says about two cases. Okay, the first case is that the resultant of two forces P and Q are R. Then second case is, if Q is doubled, then the new resultant is perpendicular to P. Okay. Now the assumption is that the angle between these forces P and Q in the first case will be equal to the angle between the forces P and 2Q. Okay, then from the second case we know that tan alpha, which will be the angle between the resultant and the first force, is equal to Q sin theta divided by P plus Q cos theta. This is the general form, but in the question the forces are P and 2Q. Therefore tan 90 degree, which is the angle between the resultant and the first force, is equal to 2Q sin theta. 2Q sin theta divided by P plus 2Q cos theta. Substituting 2Q into Q. Okay. Then we can get that infinity is equal to 2Q sin theta divided by P plus 2Q cos theta. Okay. In order to satisfy this equation, then the denominator should be equal to 0. Okay, that means P plus 2Q cos theta is equal to 0, which means that cos theta is equal to minus P divided by 2Q. Okay, now substituting the value of cos theta in the resultant, or in the equation for resultant, which is equal to square root of P square plus Q square plus 2PQ cos theta, we will get. Okay, now this equation can be directly applied because we have P and Q and angle between them as theta. Okay, so substituting, we will get P square plus Q square plus 2PQ into cos theta's value is minus P divided by 2Q. Okay, now if we simplify this, we will get as square root of P square plus Q square minus P square, which will be equal to Q. Therefore the correct answer is option B. The resultant of two forces P and Q is R. If Q is doubled, the new resultant is perpendicular to P. Then Q is equal to R, or R is equal to Q. Okay. That's all in this video. Thank you.